All right, we are back. This is Techmath2. We're looking at Chapter 7-8 Review, Part 3. So, number 22. We're on number 22 on the review. That is, the center is 0.0 from P outside the circle. Half tangents PF and PH are drawn. So a half tangent means that when this point and this point hit, it forms a 90-degree angle with the center of the circle. That's what a tangent line is, perpendicular to the center at a specific point on the circle. All right. PF is 41.5. OP is 47.6. So they do give us this length also. From the point outside the circle to the center is 47.6. All right, so now they want us to find the radius, OF. Okay, so look what we have. Let's draw that picture. I'm going to just draw this triangle. So there's the 90-degree angle. That's F, that's O, that's P. We know this is 41.5. We know this is 47.6. And they want us to find that. So part A is just Pythagorean's theorem again. A squared plus B squared equals C squared. Remember, the hypotenuse is always opposite the 90. So x squared is 41.5 squared equals 47.6 squared. Subtract 41.5 squared. And let's see, that is 543.51. That was 2,265.76 minus 1,722.25. That's how we got the 453.5. Take the square root of that. And we're looking at 23.3 inches. So that's OF. 23.3 inches. Okay. Next, they say find the central angle FOH. So that's not a problem because now, look, we want to find this angle. That's right here. That angle. Okay, that's what's going on. That's opposite and hypotenuse. That is sine again. So the sine of theta is equal to, remember, SOHCAHTOA. So opposite and hypotenuse, opposite and hypotenuse. So we're talking about sine. So the sine of theta is equal to 41.5 over 47.6. And so theta is equal to the arc sine of 41.5 divided by 47.6. And so make sure you're in degrees. That is 29.3 degrees. And so if you make it just, again, it's up to you if you rounded it to 29 degrees here. Actually, when I look at it here on the, which one did I use? Hold on, what are we finding? 41.5, 47.5. I'm finding angle P. Oh, find FPH. Oops, I'm finding the wrong angle. Oh, I jumped to C. This is letter C. Sorry. This is letter C. So that wouldn't be 29.3. Letter B is find this angle up here. I'm actually finding this angle down here. So if I use my calculator, is the arc sine of 41.5 divided by 47.6. So if you were yelling at the at what was going on, that was 60.7 degrees. And so if you double that, that is 121 degrees in there, 121 degrees. That's letter C. So I found this whole thing. This half of it was 61 degrees, and so that half is 61 degrees. Now, if I know this is 61 degrees, I can just subtract it to find letter B, you know, 180 minus 90 minus plus 61 rather. So 180 minus 90 plus 61 in parentheses. And so that is 30, what is that? 30 degrees, 29 degrees. So that's 29 degrees, but that's just this half of it. That's just this half of it. And so you double that, and that's where the 58 or 59 comes from. All right, so 58 degrees or 59 degrees with the 121. Because that would have been, yeah, no, that would have been 61. Okay. So if you gave me 58, that would be okay. If you gave me 59, that would be okay. I'd accept either one. It depends on when you rounded it. All right. And then letter D, find length. Oh, arc length FH. So to find the arc length, we use the 121 degrees. So arc length is equal to radius times theta. So that is, what is FO? Where did we find that? 23.3 right there. 23.3 times 121 pi over 180. Because remember, we need it in radians. And so the arc length is 49.2 inches. All right. Okay, let's look at 23. There's another one of these. So we've got a circle. Got a point outside the circle. We got A, we got B, we got O, we got 39.2 given as the radius, and they told us the outside is 48 degrees. Well, if we know this is 90 and this is 90 and that's 48, it has to add up to 360 total. Triangles add up to 180 total interior angles. Quadrilaterals, any four-sided figure, has to add up to 360. So you do 360 minus quantity, 90 plus 90 plus 48. And so that is 132 degrees. So we found this central angle, and now they just want the intercepted arc. So arc length is 39.2 times 132 pi over 180. We're just basically converting that from degrees to radians by multiplying it by pi radians over 180 degrees. And then the degrees canceled, and there we are. So that is 90.3 centimeters. Okay, 24. This is much easier. It rotates 270 times in 22 seconds. Find the rotational velocity in revolutions per second. So this was kind of easy because they gave us the revolutions. Rotations and revolutions are interchangeable. So rotation, that's the same as revolution. And 22 seconds, that's seconds. They want it in revolutions per second. Well, we already have it in that. We just have to divide the top and the bottom by 22, so it's 1 second on the bottom. So that's 12.3 revolutions per second. That's it. All right, 25. 25,400 rotations in 1.8 minutes. All right, and now they want it in revolutions per second. Revolutions per second. So this is going to require me to change minutes into seconds. So 1.8 minutes times 60 seconds in a minute, right? So that's 108 seconds. So now it's just like the one that they gave us above. Okay? So 25,400 divided by 108. You just basically do that division. That is 235.18518, but they want it rounded to the nearest whole revolution. So 235 revolutions per 1 second. Okay? Or RPS. If you just want to write RPS, that's fine. Okay, let's look at 26. They gave us 185 revolutions in 1 minute, but they want it in, what do they want? Revolutions. Okay, they want it in feet per minute, so feet per minute. So they also told us the radius of the circle was, well actually they gave us the diameter. The diameter of the circle for this problem is 7.2, so we need the radius, not the diameter. So cut that in half, divide by 2, diameter is the whole length, radius is half. So that's 3.6. All right, so what you do is you convert from revolutions to radians. So what is that? Well, 1 revolution is 2 pi radians. So we're now in radians. Now that we have it in radians, so 185 times 2 pi radians times the radius of the circle. So you're sort of finding arc length, sort of finding like the circumference, like when you roll it out, what is the linear equivalent of like rolling the circle 1 time? How far does it go? Okay? And so that, oh, and wait, one more. We want it not in inches. There's 12 inches and 1 foot. So now inches cancels, revolutions cancel, radians basically goes away because we're doing it times the foot, and that should be it. So 348.7 feet per minute. That one was a little confusing. Let's look at 27. A wheel has a radius of 6.15 inches. Angular velocity is 11.2 radians per second. So they already have it in radians per, time frame. Like we had to force this one into that. And so find the linear velocity. So this was the linear velocity for that. 27 is much easier. It's the linear velocity, v, is equal to the angular velocity, which is going to be in radians, which they gave us. And that's, it looks like a W, but it's not. It's actually a Greek letter. It's like a roundy W. And then times radius. So this is actually the formula that we did use here. It's just we had to find the angular velocity ourselves. We had to get, because they had it in revolutions. This one is not. This is already in radians per second. So all we have to do here is take what they gave us, the 11.2 angular velocity, and the radius of the circle is 6.15. And so you just multiply it and you're done. It's 68.88 inches per second. I think there is one like this on the test, like 27, where they just hand you the angular velocity and the radius. All you have to do is multiply them. All right? Okay, and then the rest of this is just kind of conversions, so let's fly through that. 28 to 34. So 28 is 75 radians per second. Is how many revolutions per second? So 75 radians in 1 second. Well, they want revolutions, not radians. So 2 pi radians is 1 revolution. Think about, one rotation around the circle. And so top times top, bottom times bottom, radians cancel. We end up with 75 revs over 2 pi seconds. We don't want 2 pi seconds, so divide top and bottom by 2 pi. And that is 11.936 revolutions in 1 second, or 11.9 RPS. 29, 1200 RPMs is how many radians per second? So 1200 revolutions in 1 minute. So we want revolutions to go. 1 revolution is 2 pi radians. That's what they want. So revs die. Just multiply it by a fancy one. Again, we did this in 115, stoichiometry, remember? And then we want minutes to go away. So 1 minute is 60 seconds. Again, an equivalency, but the minutes cancel. So we're left with seconds and radians. So you multiply that and divide by 60. You should end up with 125.66. And that is 125.7 radians per second. All right. Okay, lovely. Let's take a look at 30, 31, 32, 33, 34. And again, if you want to do your calculator to convert to degrees, minutes, and seconds, you can. I walked that through when we were doing the lecture notes. So you can watch that one. I'm just going to do these by hand. So 30, they got 180 degrees, and they want us to subtract 112 degrees, 16 minutes, and 30 seconds. So the way that you do that is you borrow a degree. So 179 degrees, that leaves 60 minutes, but we also have to take one of those, 59 minutes, 60 seconds. Just think of it as like time. We have seconds and minutes and hours. If I said 180 hours, I could also say 179 hours, 59 minutes, 60 seconds, and it means 180. Because, right, that second is actually 1 minute, that minute is actually 1 hour, or in this case, a degree. Okay? So they just borrowed the same thing, and now we can just subtract each one individually. So that is 67 degrees, 43 minutes, 30 seconds. And so there's our answer, 31, 138 degrees, 13 minutes, 47 seconds. They want me to convert this to just degrees, so decimals. So you go 138 plus 13/60ths plus 47 3600ths. Now, you might ask, well, wait, why isn't that just 60? Well, because we are going from seconds all the way to degrees. We're not going from seconds to minutes and then minutes to degrees. We're going from seconds right into degrees. So there are, think of how many seconds are there in an hour? 60 times 60, right? 3600. That's why that's there. All right, so you crank that into your calculator, hit enter. We get 138.2297 degrees. 32, 80.9751. They want me to convert it to degrees, minutes, and seconds. So what you do, you pull the 80 out. That's the degrees. 0.9751 times 60 will be how many seconds there are, or how many minutes there are. First minutes, okay? And so that is 58.506. So that is 58 minutes. All right, which makes sense. I was close to a degree, right? Almost 81 degrees. So 58 minutes, that's pretty close. Now you subtract off that 58, you take the 0.506, but you multiply it by 60, because this is minutes now, and we're going from minutes to seconds. So you multiply by 60, and that gives you, what does that give you? Where was I here? It should be about 30, right? 30.36. Half, right? Half of a minute is 30 seconds. So 30 seconds, rounded to the nearest second. So degrees, minutes, seconds. 33, they just want us to add them. Let's add them. And then they just want us to find the sine and the cosine. And again, if you want to type them into your calculator, feel free. And on the work, you can just say calculator. So 33 was 62 degrees, 43 minutes, plus 43 degrees, 28 minutes. So we add those up, we get 11, carry the 1, 5, 6, 71 minutes. That's not cool. We can't have it over 60. So you subtract 60 off, 11 minutes, and that adds 1 degree up there. So 6 and 10, 106 degree, or wait, did I add them? 3, 4, 5, 6, or did I write it down wrong? 28, 28. No, I did it right. So 106 degrees. Oh, we're not done yet. Okay, I see. Okay, so I got 106 degrees, 11 minutes, but now they want to know, okay, wait. Those are two angles of a triangle, so what's the third angle? So 180 degrees minus that. But we can't do it like that, so we have to borrow one off. So this is 179 degrees, 60 minutes. And now that's our answer, 49 minutes, and what is that, 73 degrees? 73 degrees, 49 minutes. All right, and then 34, they want the sine of, and they give you degrees, minutes, seconds. I just converted it, 0.46944, and did that, 0.22575. And they wanted the cosine of 33.2525. 83626. 0.83626 and 0.22575. So, easy peasy lemon squeezy. Degrees, minutes, and seconds.